Yes, we can start now.
Radhika, start the meeting. Hello, Radhika.
Yes, ma'am.
Please start the meeting.
Okay. Hello, everyone. Welcome to our National Space Day celebration. Professor Rajendra Singh Science Exploratory and Indian Association of Physics Teachers, IPT, is jointly hosting today's event. We are privileged and thrilled to collaborate with IIPT for the celebration of Bharat's first National Space Day. In 2023, on August 23rd, Chandrayaan 3 accomplished the safe and soft landing of Vikram lander on the lunar surface near the South Pole. Bharat became the fourth country to land on the moon and the first to land near the southern polar region of the moon. The Union Government of Bharat has declared August 23rd as a National Space Day to celebrate the remarkable success of Chandrayaan 3 mission. This achievement is being celebrated across the country with the goal of engaging and inspiring the younger generation in the field of science and technology. For today's virtual event, we have our guest, Dr. Reshma Desai, Assistant Professor at School of Physical and Applied Sciences, Goa University. From Goa. Welcome, ma'am. It's a privilege to have you with us. Also, we have President of Indian Association of Physics Teachers, IIPT, Dr. P.K. Aluwalia. Welcome, sir. Also, we have Dr. Anwane, President of IIPT from Vidarbha region. Also, Dr. Govind Lakhotia, Vice President of IIPT from Vidarbha region. Also, principals and teachers across the Nagpur city. We all teachers and principals are welcome here. Also, you all students, you all are welcome. I am thrilled to have you with us. As we explore the wonders of science. Space is very exciting and mysterious subject. We all are excited about space. To dive deeper into the wonders of space, I would like to welcome Dr. Reshma Desai ma'am. But before that, for her brief introduction, I would like to invite Dr. Seema Ubale ma'am for her brief introduction.
Thank you, Radhika. Good evening, everybody. Respected Dr. Aluwalia sir, Dr. Govind Lakhotia sir, Dr. Anwane sir, who will be joining us shortly, and today's guest speaker, Dr. Reshma Raut Desai. This is Dr. Seema Ubale. I take this privilege to introduce before you our respected guest speaker for today, Dr. Reshma Raut Desai. She is an assistant professor at the School of Physical and Applied Sciences, Goa University, and also a visiting associate of Inter-University Center for Astronomy and Astrophysics at Pune. Her list of awards is very long, but I must read it one by one. I started from the year 2014 because she is a recipient of Inspiration to Youth Award, and she has delivered more than 195 popular talks till now on astronomy and conducted sky observation. She is also conducting workshops on reflector telescope making. And now to her research work. Dr. Reshma has her research interest broadly in the study of porous material, glasses, neutron scattering, and X-ray astronomy. She has presented her research work in various conferences and was invited to deliver guest lectures at Tokyo, then 1 minute, I lost it. In Tokyo, then Bangkok in 2017, and also at Sydney, Australia in the year 2015. And since her prophecy is in that telescope making, so I would like to tell you something about our exploratory before we actually start with your lecture, ma'am. At our exploratory, as it is clear that it is Professor Rajendra Singh Science Exploratory. Professor Rajendra Singh was nobody else, but he was a physicist, and he's fondly remembered as Rajju Bhaiya, who was fourth Sarasangha Chalak of Rashtriya Swayamsevak Sangh. Before joining full-time social work, he served as professor and head of physics at physics department at Allahabad Vishwavidyalaya. Now here in Nagpur, the exploratory was started in the year 2015, but post-COVID, it could not continue, and it recommenced only last year. And this is our second year. We have started with various programs. One of the program is laboratory training program, and last year around 70 plus students were registered for this year-long laboratory training program. And this year, I am very proudly sharing that around 170 plus students are registered for this year-long laboratory training program this year. Then besides this, we are also conducting mathematics classes for NMTC, and 30 students are going to appear for this mathematics examination, which is scheduled for 31st August, that is next week. And a prominent program which we conducted last year, one of the prominent program, that was Sky Gazers Mumbai team was there to guide us there. And that's why I am very much delighted to have you today here, because of your interest in telescope, conducting telescope workshops. And we look forward to to have you here for this telescope making workshop also. So I welcome you, ma'am. I welcome all the guests for today's lecture. And now I request you to start with your lecture on space and effects of microgravity. Over to you, ma'am. Thank you very much.
Thank you very much, ma'am. Thank you. That was, you nicely introduced me. And yes, I am very much interested in telescope making, which I have been doing for last so many years. Conduct 20 days workshops on actually grinding, polishing mirrors, and then making it into a reflector telescope. Good evening, everyone. And first and foremost, before I start, let me first thank all the organizing members of this program, of Professor Rajendra Singh Science Exploratory members, as well as Professor P.K. Ahluwalia, National President of IAPT, for giving me this opportunity to be here with you all and to interact with you all on this very auspicious day, I would say, a day before 23rd of August. It was just a year ago that we landed on a moon. Today morning when I was giving talk in one college, and I was just feeling it is just few days back that this history has happened, and 1 year has passed so fast, and we are here now celebrating 1 year of this achievement of being the first country to reach to the South Pole. So let me share my screen first. Yeah. Okay. Are you able to see the full screen?
Yes, ma'am.
Yes,
Yeah.
ma'am. Yes.
Okay. Yes. Thank you. My talk today, titled Space and Effects of Microgravity. What I'm going to do in this presentation is, what has happened? I'm not able to move my slides. Okay, so in this presentation, I have 4 parts. In the first part, I'm going to speak about how vast the space is, how big the space is. Then we'll have a little bit of introduction of microgravity. And then what are the effects of microgravity on human body? And if time permits, I will speak in brief about career in astronomy, as I know most of the attendees here would be students from schools. So this is my first slide, and I always like this slide to see because it is huge. It is showing a lot of galaxies in it. But the picture that I'm showing you is a picture taken by Hubble Space Telescope, and it is just a very small part of the sky. And what you see here, okay, let me take the cursor. Every dot that you see here is a galaxy. And if you look at this picture, it looks like as if they are just neighbors, just next door neighbors. And it looks like space is as if all the objects which are there in the space are very, very close to each other. But reality is something different. All these objects that you see in the sky, they are very, very, very far from each other. And the space, my first title that I said, subtitle, is Vastness of Space. The space is huge, covering a lot of stars and galaxies, which we are going to see in my next slide. Okay, let me begin to tell how vast the space is. We begin from our own star, that is Sun. The yellow part that you see here is the Sun, and a small dot that you see here is the Earth. Only considering this distance from the nearest star to us, or our or as what you call the father of our solar system, that is Sun, the distance is around 150 million kilometers or 94 miles. Okay, so this distance of 150 million kilometers, as we define it as 1 astronomical unit. So this is my first definition here for all the students to know. Distance between Earth and the Sun, that is what we call 1 astronomical unit. And I'm going to use this unit for up to the region of our solar system. Outside that, we are going to use some different unit. Okay, so let's go to the next slide. Now, let's try to understand this. If I compress the Sun to the size of, say, football, and considering this 150 million mile, the distance between football and the Earth would be reduced to, say, around 25 meters. Okay, and likewise, if I consider the planet Jupiter, okay, which is the biggest planet and the largest planet in our solar system, the distance of that planet from the football, which is a sun, which we consider to be a size of the sun, we assume it to be a sun. The distance from Sun to the Jupiter is around 120 meters if we put it in the scale that I am mentioning here. Likewise, if we look at other planets as we go from Sun to out, Mercury, Venus, and of course there is a asteroid belt here, Jupiter. If you look at the Saturn, it is twice as far distance from Jupiter from us. Still further, Uranus again will be twice that distance, and Neptune will be thrice the distance away from it. Okay, but this is not the end of our solar system. Okay, so as of now, we are only talking in terms of astronomical unit distances. Now, outside this orbit of Neptune, and then we have this dwarf planet Pluto. Outside this, if you see, there is one cloud here. There are some objects present here, which we call Kuiper belt. And Kuiper belt is that region, or it's a rocky belt, I should say, which contains some legs of planets as well as some rocky bodies, as we call them asteroids. Okay. If I go still further outside that, there is another belt which we call as the Oort's cloud. Again, this is also comprising of billions of comets in it, and the distance up to this will be around, say, 50 astronomical unit. Okay, so boundaries of the our solar system are Kuiper belt, heliosphere, which is the edge of Sun's magnetic field, and the Oort's cloud. So this is all about our solar system, and distances that we measure in our solar system will be written or measured in terms of a unit which we call as an astronomical unit, which is defined as a distance between Earth and the Sun. So let's go little outside. Let's try to explore little more. So look at this picture here. Now we talk about the scales of our universe. So this small dot that I'm showing here is Earth, where we are standing or where we are living, and this is Sun. And we have already defined the distance between these two, that is an astronomical unit, which is If you write it in terms of another unit, which I'm going to define very soon, if you write it in terms of a light year, a unit of, again, a distant measurement in the universe, it is around 2.2 by third of the millionth of the light year. The next nearest star to us, that star is named as Proxima Centauri, which is at a distance of around 4.2 light years. And then we have many more stars. One among them, my favorite, is Aldebaran, which we also call Rohini Nakshatra. Aldebaran is at a distance of 60 light years. Again, the nearest galaxy to our Milky Way galaxy is Andromeda, and it is at a distance of 2.5 million light years. So what is this light year? So let us try to understand this, and then we'll know a little more about that. A light year is that distance traveled by light in 1 year. A light travels distance in 1 year, the amount of distance it covers, that is what we call a light year. So how do we define that? So it is, you can calculate it this way. In a year, you have around 365 days. 1 day is 24 hours. 1 hour, there are 60 minutes. Every minute, there are 60 seconds. And speed of the light is 3 into 10 raised to 8 meters per second square, right? If you multiply all this number, what you get is 1 light year. So 1 light year is equal to 9460 and 9 zeros, or you can write it as 9.46 into 10 raised to 12 kilometers. This is just 1 light year. And as I told you, the first star closest to our sun is 4.2 light years. Another one is Aldebaran, 60 light years. And then we are talking about the galaxy, which is our neighboring galaxy, but which is at a distance of 2.5 million light years. Now, what does this tell us? What does this mean? So when I say this object is at a distance of 4.2 light years, what it means is when I'm looking at it today, I will not get to see it as what it is today, because the light from this star has started 4.2 years ago, and now I'm receiving it. So I will see what it was 4.2 years ago. Again, Aldebaran, I will see what it was 60 years ago. Okay, what it looks like today, or what is happening on its surface today, I will know after another 60 years, because light has to travel that much distance. Again, let us go a little far outside our Milky Way. The first galaxy closest to us is at a distance of 2.5 million light years, which is Andromeda. So you can imagine. So this is one of the galaxy which we don't need a telescope to see. We can see it through our naked eye as well, right? November, October, December, these are the proper time for us to look at this galaxy and appreciate the power. We must appreciate the power of our eyes, that something which is at a distance of 2.5 million light years, we are able to observe. But what we see is what it was 2.5 million light years. So I have only talked about 2 galaxies. One is our galaxy, Milky Way, which contains all these stars, and then Andromeda galaxy, which is its neighboring star. So this is, you can say, one region of the space. We are going to look at how large, how big the space is, space that is around us. So fine, a very beautiful picture of the sky. What you see here, each and every object that you see here, these are stars, except 1 and 2, which are galaxies. Rest all what you see is a star. Again, it is a small patch of the sky which gives this many stars. Okay, now how many stars do you think will be there in one galaxy? So in a galaxy like a Milky Way or an Andromeda galaxy, we have around 200 billion stars. Okay, and we have been talking about light year distances, which is 60 light years. Then we have stars that we can see at night, which are 200, 300,000 light years away, and 200 billion stars in one galaxy. Okay, now this what I said is in one galaxy. Then how many galaxies are there in the universe? So the same picture that I've shown in the beginning, look at this. There are around 100 billion to 2 trillion galaxies in the entire universe. So if you multiply this to the number of stars in each galaxy, you will get a huge number. Those many numbers of stars may be present in our entire universe. but we are not able to reach there, to every star and get information about each one of them because they are very far. The certain distance that human being could have covered, we have already covered. A lot of work is happening in space, in international space. Our Indian missions are going to moon, and the next would be on the Mars, and then we will think about all these far objects, right? But to do all these, technology has to be developed slowly, and that work has been going on, I think, since 1957. That is when the first spacecraft was launched in the sky. So here what I mentioned to you, there are so many galaxies here, and we just talked about two galaxies which are close to each other, neighboring galaxies, Andromeda and Milky Way galaxy. So this, let's look at only one unit, that is one galaxy, which is a Milky Way galaxy. This is of course, an artistic picture of Milky Way galaxy, because we cannot get the entire picture of Milky Way as we are in it. We are on one side of it. But what we can get, the picture, many a times, if you go at the night sky, you can see a patch of white patch of stars, okay, in the sky, which is one arm of the Milky Way galaxy. Okay, now let's look at how lengthy or how big the Milky Way galaxy is. You imagine that you have a bike which can travel at the speed of light. I hope you understood what I'm trying to say, all the students. You have a bike which can travel at the speed of light. Then for you to cross from your house to your friend who is staying on the other part of the Milky Way, it will take 1 lakh years, because this distance, this diameter of Milky Way, that length is around 1 lakh light years. So you have to now keep on imagining what I'm saying here is one galaxy is length is of 1 lakh light years. Two galaxies close by are 2.5 million light years away. And then I've talked about 200 to 2 trillion galaxies. So imagine, where is this present in the space? How big the space is. Now, whatever I said, so many galaxies present, it has been modeled. A model is made about that to understand how big the observable universe is, or how much we have been able to reach. So this is one galaxy. Then let us say two galaxies, neighboring galaxies, as I've already talked about, Milky Way and Andromeda, at a distance of 2.5 million light years. So many of such nearby galaxies form a cluster of galaxy. Okay, so this is a cluster of galaxy. This cluster will have around 100 to 1,000 galaxies, a group of galaxies which is 100 to 1,000. Okay, so that forms one cluster of galaxies. So there would be many such clusters in the universe, clusters of galaxies, which are hosting around 100 to 1,000 galaxies in it. Okay, still go little, the model, you can model it in such a way that next we have a cluster of galaxies clustered together, which you call it as a supercluster. So you bring galaxy clusters, a dozen of galaxy clusters together, and that forms a supercluster like this, or more better picture would be here. So this is called a supercluster of, or it is called as Perseus supercluster. And this is about, actually this is made up of chain of around 12 or more than that galaxy clusters. Okay, and how big it is? It's about 300 million light years long. The length of this galaxy, try to imagine, it is 300 million light years long. So likewise, there would be many superclusters in the entire universe. Okay, now which are kept apart, like one supercluster to other supercluster distance is around again 180 to 240 billion light years. We can only imagine all these distances. I've already told you what is light year. Now this cluster, what I'm talking about, like this is a Perseus cluster. So here in this model, one cluster is placed here. So you can see many superclusters here. Capricornus supercluster, Sculptor supercluster, Perseus supercluster is somewhere here. So many of these superclusters together form, you can call it, say, supercluster, right? And this entire ring, okay, and here it is mentioned that this small region of the this model specifies the small region is only 100 million light years. So you can measure the distance from here to here. And this is one super cluster. Now I put this dot here. Okay, so the picture that I've shown here, this is a dot here. Okay, so there are so many super clusters here, and this is the boundary as we know. Okay, observable universe. Okay, so in this model, this line, this scale given here is around 1 billion light years, and as you know, universe existed 13.7 billion years ago. So this entire region, what we can see, observable universe, as what we call is 13.7 billion years ago. So here I've marked the Virgo supercluster in the center somewhere. Okay, so this is what I wanted to tell you about how big the space is. Okay, how large the space is, and how much have we studied. We must have looked at very small part here and not the entire space, right? Just a little part of this has been studied, and that also not too completely. We still have much more to do in this particular area, but still we have to appreciate that the first space exploration that humankind started, that was to launch Sputnik in the space. That was in 1957. Okay, and I've shown you the picture of Sputnik here. And after that, of course, both the countries, US and Russia, who used to be called pioneers in space studies earlier, they had kind of competition between them of launching different satellites. And that went on for a long time. And then in just a span of 4 years, from 1957 to 1961, we had a first human being who went in the space, that is Yuri Gagarin. Okay, he orbited in the ship that was named Vostok, and that was on 12th April 1961. It was just in a span of 1957 to 1961. In just 4 years, the mankind made so much advances in technology that we could send a human being in the space, right? Okay, and after that, as you know, there have been a lot of such expedition. People have been going in the space for experiment purpose and also for tourism purpose, as a space tourist also, right? Now what is going on in the human mind is that it's not just few people to go to the space, but we want many people to go and stay there and have a separate kind of life there. Okay, so possible places where people think human being could go or stay is, one is of course moon, second is Mars, but of course you need to do lot of experiments before that happens. Apart from that, there is one more idea which is floating, and that is we can have a space colony, okay, which would be something like this, completely different, a space colony. And this, what I've shown you here is just a picture. It's not the real one. It's an artistic picture. How it is going to look like, or how it is going to be inside. So say thousands of families are shifted in the space colony. Suppose if their dal bhat gets over, then they cannot come back to Earth, right? So all these things has to be there. We have to be able to grow vegetation, and all sorts of life supporting system that we have on Earth have to be there. So we really need lot of people to work in this particular area so that this becomes a reality. And it is a must for us to have this kind of dream to go in the space and have a colony there, right? So I'll also give you in brief about, this is not just that, people will be shifted as in the colonies, but we already have people going in the space as a tourist. I am from Goa, and Goa, as we know, is a tourist destination. But now we have another biggest and very beautiful tourist destination, that is space. Why I said it's a tourist destination? Because it's really like whatever videos I've seen from the astronauts who go in the space, they always speak about them, and they say it's very beautiful. First of all, the night sky there would be very shiny and bright, and you can identify all the planets and stars very nicely. You can see galaxies also because there is no pollution, right? Apart from that, observing our beautiful Earth rising and setting would also be another entertainment for people who go as a space tourist there. So this one was Dennis Tito. He was the first space tourist who went in the space 2001. And after that, a commercial space tourism had started. And the first person in commercial tourism was Mark Shuttleworth. Okay, and then it followed, many other people went. Okay, this lady, Anusha Ansari, I've actually brought this picture because all these idea of space tourism and having somebody go to the space in a spacecraft, okay, which was specially built, okay, it all happened because from her family, someone announced the prize for somebody who can build a spacecraft which can go to the International Space Station with 2 people, okay, and take them there, okay, wait there, stay there for 6 days and come back successfully. Okay, if somebody could make such kind of a spacecraft, then the prize was announced, and that prize was won by 3 individuals, and that is how that spacecraft was made, and the our idea of space tourism began. I have to mention this. This is John Glenn. At the age of 78, he went in the space. John Glenn actually is an astronomer only, and he had been to space earlier as well. But why did he go at the age of 78? And this was at the time when NASA wanted to do some experiments on aging. And they just declared anyone wants to come forward, okay, who could be an kind of guinea pig to be taken to the space to do experiments on aging. And although he was a senator, MLA there, he came forward and he was taken to the space. Now, there are a lot of misconceptions, and I'm going to tell certain things in my future slides. You may feel, okay, it's so dangerous to go, but I have to mention by looking at this slide here, John Glenn went in the space at the last time, maybe at the age of 78. And after he came back, I think he died just 4 years ago. That was after 4 years after he went to space for the last time. So after he came back, again, he lived a very successful life and lived for a longer, I would say, lived a longer life in spite of all those changes that happen to human body when you are in space, and when you come back, you regain back. Now, I just talked about, people going in the space as a tourist. Then where do they go? Okay, and where do they stay? Because we need a hotel to stay, right? So as of now, we don't have a hotel in the space, but there was a Bigelow Aerospace who tried kind of hotel in the space. That was just the trial. But at present, all the astronauts or the space tourists who go in the space, they go to this International Space Station. International Space Station was launched in November 1998, and it is still working. It was supposed to be retired a few years ago, but it is doing very well, and all the information, all the experiments that are happening there for last so many years, for 20 years or 25 years, there have been a lot of experiments happening here, and we are getting a lot of information as what to do or what not to do in space, and what kind of experiments can be done in space gravity under zero gravity, and whether we can grow plants there or not. All those kind of experiments are happening there. So of course, this was initially a joint venture of 5 countries, 5 space agencies, and now I think around 15 countries are a part of this International Space Station. And this was, of course, first human being, people started staying there since 2000, right? Now, I just thought of keeping this slide here because, see, this is International Space Station, and you have Sunita Williams and her partner, I think, John Lopez. What you can see here and here both sides, these are nothing but solar panels. So if you look inside the spacecraft, it is full of all electrical gadgets. And we don't see any electrical wires being taken from Earth to supply power there, right? So what do we have there is solar panels. So completely dependent on solar energy, entire system is running here, and it is running for last so many years for all the spacecraft which are moving around the Earth, right? So that is to be appreciated, and we need to use that in our life as well, to use solar power more and more. So again, this is Sunita Williams and her 2 partners. This was a very old picture, somewhere in 2007, I think. That is when she had been there. Okay, now let's come to what is gravity and what is microgravity. Okay, so we all know gravity is something attractive force between any two objects, right? Or we can say that it is a force by which a planet, any other object, drawn towards second object, towards the center of the other object. So that is what we call a gravity. Okay, now this force of gravity keeps all the planets orbiting around the sun. Okay, because sun's gravity is highest in our solar system, which is around 274 meters per second square, and it holds all the planets together. Earth's gravity, it is 1, or the actual one is 9.807 meters per second square. Moon's gravity is around 1.6 of that. Mars gravity is 1.3 of the Earth's gravity, you can say. Jupiter, it is 24.79. Saturn is 10.44 meters per second. So these are the gravities. So gravities are different on different planets. So your weight on each of this planet would be changing, right? Will be different. Now let's have an example. Let us say weight of some person on Earth. Let us consider it 1 unit, or let us say 100. Okay, so let's say 1 unit, or let us say it is 100. So if the weight of a person on Earth is 1 unit, its weight on Venus, depending upon its gravity, will be 0.9. Look at the Jupiter, it will be twice than that of Earth. Again, Neptune will be 1.12, Uranus 0.88, weight of Saturn, weight on the Saturn will be 0.9, and so on. The mass of the object will remain the same. It does not change when you go to this object. What changes is due to its gravity. Okay, yeah. So then let's come to what is this microgravity. Okay, so we know now what is gravity. Gravity is something, it is attractive force between any two objects which binds object together, or which binds all the planets in the solar system to the sun, which keeps them moving around. So what is a microgravity? And usually we use the word zero gravity. Okay, so microgravity is a condition in which any object or people, they appear weightless. They feel as if they don't have weight. Okay, and when I say microgravity, micro meaning 10 raised to minus 6. So it is mu g, microgravity. So very, very, very small. It does not mean no gravity. It means very, very small gravity. So microgravity is very small, as found in, like when you have a free fall orbit, or when you are in a space, you experience microgravity. Okay, if you drop something from a very high tower, you have a free fall, right? The effects of this microgravity are observed, are seen in astronaut, and what do you see? You see that they are floating in space. Objects or astronauts, whenever you see them in space, they are floating. That's one of the effect of microgravity. Okay, now there are 3 different ways by which you can create a microgravity kind of environment. So one of the way is, you travel far from Earth. As you go away from Earth's surface and go through the different layers of Earth, okay, Earth has different layers. Okay, as you go away, you will feel that your force of attraction towards Earth goes on reducing. Okay, and what happens is, as you go into deep space, okay, the effect of gravity will be reduced by attenuation. Okay, second way of creating a microgravity, that is what I said, free fall, by falling. And third is, you can orbiting around any object, or around the Earth, or out of the Earth's orbit. Okay, other important thing in microgravity is that, okay, it is like in gravity, under gravity, when we are on Earth, if someone tells me to move an elephant, I will not be able to push the elephant here under gravity, right? But if the elephant is in space, I am in the space, I will be able to push that elephant with my fingertips, because both are weightless. I will not even feel that I am pushing an elephant. So microgravity can allow us to move objects weighing thousands of pounds or hundreds of pounds with our fingerprint, or with the fingerprints. So when I say microgravity, it doesn't mean that the gravity is entirely absent. What it means is the effects are minimal, okay, and you feel the sensation of weightlessness, and that is what we refer to as zero gravity, right? Again, in microgravity, what happens is to an object, to any object or astronaut, they appear to float, as I mentioned just now, because they are in the continuous state of free fall towards the Earth. But they are not falling because they are moving forward in the orbit at the same time, right? So they do not get closer to the Earth. So this unique condition is utilized in space research to study the effects at low gravity on our physical, biological, and all the chemical processes, okay, which are completely different in space and then on Earth. So all the biological processes, chemical processes, physical processes that we do or that we have on Earth, when we go in microgravity, that is in space, would be completely different. Okay. Some of the examples I've shown here, this is like, you have this is under gravity, okay, when on Earth. So you have this ping pong ball inside this, nicely settled. As soon as you take it to the microgravity, it will start floating. A very beautiful example is flame, okay, candle flame. If you look at, this is what you see here under gravity. Because of the convection, buoyant convection, the flame is taking the shape of a teardrop, okay, whereas the same flame you take in the microgravity, due to the surface tension forces, it will try to acquire a minimum surface area, and that, what is the minimum surface area that we can shape, that we can get, is spherical shape. Okay, so this is what happens in microgravity. Again, I think I can't see the top part what I've written here. What do you mean by weightlessness? Object mass is same, but it would register 0 on the scale when we are on some other object. The weight of an object, as I mentioned earlier, depending upon whether you are on Earth, Moon, or any other planet, it will be different, but the mass will remain the same. Okay. Now, this kind of situation, you don't need to go in space only to experience this kind of weightlessness. Many of you children have experienced this kind of weightlessness without knowing that we have experienced it. That is when we go to play. That is when we go in the park, right? Amusement park, when you have a roller coaster ride. So roller coaster ride meaning it goes up, it goes dip, it goes up, it goes dip, right? So when it goes up in a parabolic hill path, that is where, you are taken up there, and for a few, very few seconds, for a brief period, you feel weightless, and then again you come down. Okay. So weightlessness, feeling of weightlessness, is one of the biggest difference between Earth and the space, right? Now, this kind of experience of microgravity or zero gravity experience, not necessary that, as I mentioned, everyone has to go to the space only, but you can get this experience in a plane called zero gravity plane. As I've shown you the picture of it here, you can see people floating inside. This is a zero gravity plane, okay? And what it does is and I've shown you the diagram here. So it starts from here. It has this parabolic path. It moves this way. When it acquires this top position at an angle of 50 degrees, that is where you get to experience weightlessness or zero gravity for very few seconds, say 20 seconds. Impact will remain in this period for a few seconds, and when it comes down, once again, everyone will be back to normal. So people who want to experience this, of course, can go and experience. And also the people who go in the space, astronauts or any other people, have to get training in this kind of zero gravity plane. And this is what happens. This is inside of zero gravity plane. As soon as you reach that peak of the parabola, everyone will start floating. And especially for women who have long hair, this is what happens. But yes, of course, I must mention, I think I have written here, how much to pay to go to this, to have this lifetime experience of weightlessness for 20 seconds is $7,000 is what you have to pay, and you can go. So there is no other requirement there. You need to have amount of around $7,000 with you, and you can go and play there. Okay. So in space, when astronauts are in space, this what I'm showing is, of course, in the International Space Station. You can see 4 of them, and they are nicely enjoying with some oranges also floating along with them. right? And maybe they are playing with that. So in space, people do not walk, they just float. They float inside their spacecraft. Why? Because what is there inside is microgravity. So as I mentioned, it is very easy to move any heavy object under microgravity. Okay, so they can move any object, any 100 pounds of object, weighing object, they can move it with the tip of their fingers. Some more pictures which will inspire you again to go to the space. Maybe you can see eating. Okay, I must mention here that it looks very nice, but every task that you do in space, as what I have seen in various videos, it looks very tedious. Some of them is interesting and really entertaining, but some of them are very difficult tasks. Okay, now here, in order to eat apple, they also have to little bit running around and catch the apple, right? So, but you can see they are nicely enjoying it, and here they are playing the apple, keeping on the tip of their finger, they are moving it around, right? Exactly as I said, for females, this is what is going to happen if you go to the space and leave your hair like this. And of course, the questions would be there in minds of people. How do you shampoo your hair? I have a video, if it is working, I will show you. But let me just, if it's not possible, then let me just explain here. You have to comb your hair upwards, and shampoo is like, or washing your head with a towel is like you just take few drops of water and shampoo and just put it inside and just wipe it with the tissue. That's how you clean yourself. And then how do they sleep? This is Sunita Williams. This was a very old video picture that I've taken. So she's inside. This is her bed. She's inside this jacket. If they come out and sleep, they will float around. So they have to close this, right? So this is how they sleep. Now, when you are in the space, if you want your body to be intact, you have to work for 2 to 3 hours a day. You have to do exercise for 3 hours a day at least. Otherwise, you will be shrinking and all, right? You will not be able to work at all. Same thing is true on Earth. If we do exercise regularly, we are very active, and if we don't, we feel very lethargic to do any kind of work, to get up in the morning and so on. But in space, when you're there, it is compulsory for them to do exercise for nearly 2 to 3 hours. I will show you one more picture here. Okay, this is Frank Rubio. So he was in the space for, I think, around 1 year. He stayed there in the space for 1 year, and quite a lot of experiments he did. And one of the experiment that he did was growing tomatoes there. So you can see here the tomato plant, and he got his first tomato. This was the one. But when I was reading, I found that he said when he came back to NASA also, he was not able to find where that tomato went afterwards, because maybe it floated somewhere, it went out. So first he thought maybe his colleague must have eaten it or used it for preparing something, but that did not happen. But it just went because of the weightlessness. It went away. So this is how his tomato garden is that is shown here. Again, everything is challenging. Okay, liquid is very, very challenging thing to manage in space, right? So what you see here is water. If you just bring out water droplet, it becomes something like this. Again, once again, this is also because of surface tension forces, that all the water droplets, they try to come to a minimum area, and that is this area. So it somewhat kind of becomes like a jelly. Again, now I'm talking about some of the health risk for people who are traveling to space, or who stay in space for more than a month or so. Okay, so what happens to their body? They have some damage done to their DNA by radiation exposure, some bone loss, calcium loss, some loss in the muscle, blood pressure changes, okay, when you are living in the microgravity, and that will have some impact on your heart and on your brain as well. So let us see what is happening there. So when we are on the Earth, now this is on the Earth, our muscles will move the fluid, blood fluid, or whatever fluids are there in the body. Muscles will move them upwards, and gravity will pull the fluid downwards. So the process keeps on going everywhere. So blood or the fluid spreads evenly inside the body everywhere. This is what happens on Earth under gravity. But when there is no gravity, Now what is going to happen is, due to microgravity, the muscles are no longer to function to push the fluid out. So, there is no gravity to push the fluid down. So what is happening is muscles will push all the fluid up. Okay, as you can see, it is going up, and it gets more towards the head part of, or to the brain. Without gravity, fluid will be pulled near the chest, heart, and to the brain. Okay, so it shifts from legs and up towards the head. So in that process, what happens? There would be some increased intracranial pressure. Okay, and initially, when they go in the space, they would feel a little heavy head or some kind of bulging and so on. But later on, they get used to it and nothing happens. That's because they are weightless. They don't feel anything there. So entire changes that happen to a human body is shown here. Some reduced mechanical pressure here, some puffy face due to blood redistribution towards the face, risk of cardiovascular problems, or spherical shape to the heart, because heart won't be, it is not required to function a lot. Okay, because you don't need a lot of energy to move from one place to the other. Reduce muscle volume, bone loss, some problem with the kidney, decreased leg circumference, and so on. But need not get scared, because when they come back to the earth, everything becomes normal again. I must have said it little later, but I thought I must say it right now. Okay, so what happens to your eye? Okay, again, fluid pressure, which is moving towards your head, causes some damage to the optic nerve compression, flattening of the eye, back of the eyeball, and optic disc swelling or edema will be formed. So something like that happens, something this shaped eyeball you will get. Again, as I have told you, shrinkage in the heart. What is happening is the number of red blood cells decrease by around, say, 15% after a person stays there for a month or so. Here, if we have blood cells, red blood cells decreasing, then we have a problem. But here, when you are in the space, no problem at all. But what happens is around 15% of the red blood cells will be decreased. That will be due to which there will be change in the blood volume, and that will affect the heart. If you have less blood volume, then your heart doesn't need to pump as hard as possible. It is not required. But nothing happens, right? It also takes less energy to move around the spacecraft. You don't need energy because you're not pushing yourself. It is somebody pushing you there. The microgravity is moving you from one place to the other. You don't need to push yourself. So because it no longer has to work, has to do a lot of do its regular work, which it does on the earth, heart will shrink in size a bit. Okay, so but still you can see, although I told you all these things that are happening, look at these people who are in the space. They are nicely enjoying playing there, because this affects, they are not able to experience at that point. Initially they feel, and now they are completely weightless. Only when they come back to earth, they will feel heavy, because once again the blood will start moving uniformly throughout the body, and they will forget how to walk, because they are not walking in space for many days, some of them for months and some for a year. So they have completely forgotten how to walk. So when they start walking after coming back on the land, they are not allowed to meet people. They are kept in a very different environment, so that slowly they regain all the, it's like how a new child starts walking. So that way they will start, and after around 15 to 20 days, once again, everything becomes normal to them. So everything comes back to normal. Okay. So this is the beauty, I would say, in the sky. So I have a video here, and I will try to play if it's working. Let me see. This is one of the astronaut in space. He felt like having pizza. So he wanted all the material, and then when the next crew went, the officials sent them all the material required to prepare pizza, and they were able to prepare pizza and enjoy it. So that is what is shown here. I will not show you the entire video. Let us see if I have little time. Yeah. So it is floating. Again, it's a difficult task to bring it near your mouth and have it, right? Okay, fine. Let's go ahead. Again, I was talking about how they drink water in space. So he's just feeling the water. He's speaking in some other language, even I don't understand. But let me say what he's doing that. So he feels the water in that water bottle, and now he'll slowly, again, it's floating. One of the way to drink is, of course, here. And now see what happens. Water started coming out from that. Just have a look at that. How water comes out. We have seen water falling down, and here water is coming up. And you can see it's like a jelly. It tries to, as I said, tries to occupy the minimum surface area. And see how he is going to drink water in space. Drinking water is also a task. Yes. Okay. So this is how they drink water. Now it's around 24 years that International Space Station, astronauts have been staying there, okay, orbiting around 250 miles above our planet. Okay, and our International Space Station is the only laboratory that we have in microgravity to perform some research under microgravity. During some okay, kind of research which they are doing there, that is only for the sake of doing, but this also helps us to explore still further into space, and it benefits us back onto the Earth. I have mentioned here some of the experiments that they have done, and I will not going to read all of them right now. These are some of the experiments that people have carried out in space in last 24 years. Just 1 second. Okay. So fundamental disease research, discovery of steadily burning cool flames, new water purification systems they have developed, which are very unique. Okay. And when we will be in crisis, maybe we have to adopt that kind of system. So what actually they are doing is how they are purifying water is, I will only mention about this. They purify the urine and the sweat which comes out from their body, and about 95% of it they get it in the pure form of water. And in one of the video, actually, if anyone wants to see, they have very nicely mentioned how they do this kind of water purification under microgravity. Okay, so these are all the experiments that they have done, including 3D printing in microgravity. Okay, so as I've mentioned, only 1 or 2 slides, 2-3 slides I will show on career in astronomy. That is for the students who are watching this session today. Now, it is very important to make a career. Okay, and what do you want to do is a question which everyone has at this particular age, right? But career is a must. You have to have a career of your own. Okay, but if you want to take science as a career, you must keep these things in your mind, that whatever work you do will help the mankind to understand the nature in a better and better way. Also, you will get to know various aspects of life. It may be physics, biology, chemistry, any other science you're working with. Always you are learning new and new things every day when you're doing some work with science, right? And also nowadays you get very good scholarship if you are doing research in any institute, whether it is IITs or any other local universities. Also you get a pretty good scholarship when you're doing your PhD or research work. But the statement here I want to make is making a career is very important because that makes independence. Coming to the astronomy, astronomy is very appealing because it is addressing some of the very basic, most important questions as to who we are, what we are, and where we are come from. Okay. And if you want to consider a career in astronomy, I must say you must be motivated just by the love to discover something, love of discovery, and to get some new knowledge. This studies, astronomy studies, it is not meant only for physics people or maths people. There are various branches are involved in this. So who can come in this field? Physics people, because they basically work on light, matter, and energy. Mathematics, because they talk about relating time, they work on distances, calculation of energy, and so on. Chemistry people can study the chemical makeup of atmosphere of surfaces of planets and other objects. Geology is required, of course, to understand dynamics of planet surface. Of course, we need computer science because we need to develop tools and methods to do the analysis. But the key point that I want to say here is to remember that astronomy and astrophysics is a branch of physics, and you need to have a very strong foundation in physics and mathematics in order to have a successful career in astronomy and astrophysics. So when I say strong foundation at this age, wherein you're studying in your school and high secondary, make your concepts in physics and mathematics very strong. I have mentioned very few institutions here. There are very many leading institutes in India who are involved in astronomy research. Of course, there are IITs, IISCs, IISc, IITs, ISERs, and also many universities in India are having astronomy research now. So who can become an astronomer? Anyone can become, provided you have these two qualities. You need to be curious, you need to have imagination power, you need to be very creative. Okay. And of course, to all the female candidates who are in the audience, you must say that we can also make it like all these Indian women have. What we need to do is keep calm and believe in what you can do for yourself. What you need to do is follow your passion, set your goal, prepare yourself, and work hard to explore the universe. Thank you very much. I hope you have liked this presentation. And if you have any questions, you can ask now. I will stop sharing my screen and come back to you. Yeah. Yeah. Hello, everyone. Yeah. Radhika, you are mute. Yeah, unmute yourself. Yeah.
Hello. Before Radhika unmutes herself, I would like to ask one question that regarding the microgravity facility. Do we is there any provision to have such a facility, or means those who are going to the space stations, are they given such type of training or?
Yeah. See, one of the thing I mentioned is zero gravity. That is zero gravity plane. So
Yeah.
that is not only for them, but anyone can go there to experience microgravity. And of course, the people who are going in space as astronauts or as a tourist or just to stay, experience the life in space, they are given training underwater. Okay, so that training is given to them. Yes, there are facilities like that.
Anyone else is having any question, want to ask any question? Or you can go ahead with Dr. Govind's presentation. Govind, you can go ahead.
Okay, there was one question. A question says, what did you do to become an astronomer? Okay, I am an amateur astronomer. You too can become an amateur astronomer. I have not gone to space as of now. I have done my education in master in physics and then PhD in physics. Since this was my hobby of observing sky, which is I think for last 20 years. Okay, I have been just taking my telescope and showing people how the sky looks, and I was happy with that as an amateur astronomer. But I never knew at that point that even I too can do a research in astronomy. And it just started when I went as a teacher. We have to do refresher courses. I went to attend refresher course in Ayuka, Pune. That is where I interacted with Dr. Jayan Randikar and many other people there, and we got I actually saw that every physics that I have learned is used in astronomy. Astronomy is not something that I am doing only. That is observational astronomy. It's just one part of it. Every physics, every mathematics that I have learned is used in astronomy, whether it is, thermal physics, classical physics, quantum physics, everything is required. And for that 1 month, I think that changed my mind completely. And after that, I applied for this associateship of Ayuka so that I could also work in this particular area. And yes, I am doing this work now, but I have not been to the space. I, as of now, did not get that opportunity. But to all the students, you can please aim to do so. Yeah. Yes.
Yes, thank you. Thank you so much, ma'am, for your wonderful and amazing session. I will I really would
Radhika, just
like
just
to
just one.
go to that space colony.
Okay. Radhika,
Yeah.
just 1 second. This I think same student has continued her
Yes,
question,
yes.
and she wrote that she wants to become a scientist and astronomer. So maybe her question is what she should do. So this is always a question, and mostly school children and parents come and ask, my daughter wants to become, my son wants to become an astronomer. What they should do now? What you should do now is study what is taught to you in your school, study everything, physics, chemistry, biology, mathematics, everything. You just gain knowledge. Okay, once you complete your people who are doing engineering also can go in the field of astrophysics or can go in the field of astronomy, and people doing math, as I have already mentioned, you may do MSc chemistry, MSc geology, MSc physics. But if your aim is to go in the field of astrophysics, then you have to go after MSc in that particular direction. You have to go for research in that particular area. And there are various institutes in India wherein you can go. Okay, yeah, Radhika, I continue.
Yes, thank you so much, ma'am. I would like to ask other students if they have any questions.
Yeah.
Those who have any question, they can unmute themselves.
So by whom I got inspiration? Okay, first of all, whatever I'm doing, I'm inspired by all the people around me, I should say, my teachers. Yeah, that I had that aim in my mind that I want to do something different. So that is what I think you should have first. And your inspirations are always your parents, your teachers, all your elders, and of course, the people who have made this kind of work. There are many in India. I need not name one person. Okay. Yes.
Yes.
Excuse me, ma'am.
If someone wants to ask question,
Yes, ma'am.
yes, you
Can
can
I
ask.
ask
Yeah, sure.
how do astronauts co- co- uh, contact from their families?
Contact their families. I know they contact the space stations. Okay, from NASA, they have a control room, so they have a contact there. We do have a technology for that. They do have a technology for that. Exactly what I have no idea about, but yes, they do contact. But I don't think they contact their family in between.
Okay, thank you, ma'am.
Hello, ma'am. Are there concerns about space pollution due to space tourism?
Um, as of now, no. See, pollution, when does it come? Even on the earth, pollution is created by we human beings only. We throw out everything here and there, and that is how it happens. Now, when you are going in the space, you have a responsibility. Okay. every waste which is there, even the excreta, all that is brought back, kept in proper condition. They take care that nothing moves out here and there. I don't think there is pollution right now there, but many of us, when we go there, we might create pollution. Okay, and I have mentioned in between somewhere that every task that you do in space is very, very, very risky and difficult. Like there was one work which was being done, some kind of repair work to the International Space Station outside. So the astronauts were doing that work. So they had to fix a nut. So they have to be so careful that if that nut by mistake also slips from their hand, when on Earth, when we want to do some cleaning of the fan or something, we always have somebody standing next to us, and we always order them, give me this, give me that, and all. But there you don't have anyone. You have to be very careful because you have that responsibility. If that nut falls out there, it will never come back to you. It will float, keep on floating, and that way we can add junk in the space. But these people who go there are very well trained, and I don't think they have any intentions of spoiling that region as of now. That's why I think many countries are targeting to go to space again, because we are in a polluted environment now a lot.
Okay, thank
Thank
you,
you. Yeah, nice questions.
Excuse me, ma'am.
Yeah.
Ma'am,
Yes.
which competitive exam should we give to become a scientist or an astrologer?
Astrologer, no. Astronomer, completely different, two different fields. Competitive exams, there would be like different. For example, for engineering people, and also for master people, you have to clear your GATE, NET. Okay, then there are exams. If you want to go to IUCAA, they have their own exams. So you'll have to find out from the site when these exams are announced. Then there are some exams like JEST. Okay, these are the exams that would once you answer, you have to go and answer their interviews, and you would be selected to do some research work in India. If you want to go abroad, clear cut. You answer, for some people it is you answer some graduate record exam, TOEFL, and then you join institute whichever you want to join, right? And nowadays I would suggest this, since there is a lot of competition, it is always better to have some kind of publication. So when you do your master's project, or when you do your engineering project, and if your interests are to go in the field of astronomy, please take a project in that particular field and try to have a publication. I have a student who got admission for PhD in King's College, I think that was London, after BSc. And this was a very unique thing, because usually for research and all, they take after masters, or in abroad it is after 4 years degree program. In India we have 3 years degree program, right? But this boy, although he topped in physics in Goa, he did not come for masters, because he said, I want to do astronomy. And he just kept applying here and there, and then in 1 to 3 universities contacted him back. The reason for that was, we used to conduct some kind of honors program, physics honors program for them, and in which we had conducted 3 astronomy programs, and it goes on for the 3 years of their undergraduate program. So it becomes kind of 1 degree. So when that university considered his case, they considered it as 3 years of physics, and at the same time he did this kind of honors program, so that they considered to be the 4th degree. And that is how after BSc he got admission for PhD. So we have such cases like that. So if you want to go abroad, yes, you need to directly write to those universities wherever you want to apply, and after your masters, of course, or after doing your engineering. And in India, the competitive exams that you need to do, of course, are NET or GATE exam, and respective institutes will have their own exams, like ISRO or any other. TIFR have their own entrance exams, or they also take based on your GATE or NET score, and they have their interviews.
Thank you, ma'am.
Excuse me, ma'am.
Yeah, thank you. Thank you, everyone.
Ma'am, I have a doubt.
Yes.
Ma'am, as any astronomer cannot meet family, then why would people want to be astronomer? Because no one wants to leave their family.
Cannot, nobody will go and stay there forever. They'll come back, right? They don't stay there forever. Few days, some of them for a month, and very few maybe 1 year, and they do come back. We do go on vacation, right? Don't we? Okay. Don't worry about that.
Ma'am, are there chances to live in the space actually?
Of course, see, that is what the all aim is about. So people are working towards it. At present, it looks like as if this is a dream. Okay, how could you stay in a space? As of now, we have already attained certain things like you go there, you are staying there, you are working there only in weightlessness. People have even grown tomatoes there and many other vegetation also. See, 20 years ago, when I was young like you all, I used to always think we had those phone. Okay, you have to do tring tring and you speak to people. And I used to just wonder, many of the people must have thought of the same thing, that it would be so nice if I could see somebody who is speaking to me on the phone. Okay, and that was some 20, 30 years ago. If you were to tell this to someone, they would say, "Arey, you're a fool. What are you talking about? How is it possible that you can see somebody who is very far from us, who is in different country, who is in different state? How is it possible?" But today it is a reality. We have mobiles, each one of you have mobiles in your hand, and we can talk to each other. Right now you can see me, right? So this has happened. In the same way, all the work that is happening with respect to the space research is to have kind of space colony in the space, or is to see where it is possible for us to go. We do not know. Like many years ago, when there was this dinosaur extinction because of the asteroid falling on it, such kind of thing may happen, or such kind of possibilities are there. So we may have to shift to some other place. When COVID was there was there all over the earth, that was the time people were thinking, I wish we could go in some other space and live there, right? So that's why we need to get ready from now only. Preparation for that should start now only. There would, of course, it will take many more years now, but all work which is being done, all the money which is being spent by different countries is only to have this success, that someday we will be able to go in the space and stay there forever. Okay, and of course, come like how we go from one country to other country, it is going to be like that. And tourism has already started. I've already told you a few years back, I used to put one slide wherein there were a lot of people, names were there, who want to go in the space as a tourist. To all of you, all the children here, I must mention here that it is not that only you go there when you grow up. So even at this age, there are certain competitions. Okay, and if you win those competition, they keep the prize. You can get an experience to go to the space also. Yes.
Excuse me, ma'am. I wanted to ask that it took a small amount of time between humans going to the space and the moon. But it's taking so much time for humans to go from the moon to Mars.
Yeah, because Mars is little far. We need to still study Mars. Mars is not studied that much, right? And if you know that to go to the moon now, it was stopped for many years, and after preparation again, now they are planning to send people to moon, India as well as other countries also. So definitely you need to understand the climate there. Okay, whether we human beings will be able to stay there or not. Although it is very clear that what you say, the rotation period of Earth and the Mars are more or less equal. A revolution period of Mars is twice than that of Earth. That means, if here we have 1 year, that would be, or on the Mars, when you say it is 1 year, on Earth we have completed almost 2 years. So there are some similarities. You need to have water. They have found some traces, but that is not enough. So you need to have a complete preparation. Then only people will be going there. Simply, if I tell you now that you have an opportunity to go to Mars or any other planet, but it is a one-way ticket that will be given to you, and you are not given a ticket to come back, who would like to go? Nobody would be happy to do that, no? So when you send someone, you should be prepared to bring that person back as well. So all that kind of studies have to be done. So, but this will happen soon. Okay.
Thank you,
Yeah.
ma'am.
Yes, thank you. Yeah.
Anyone else want to ask the question?
That will be the last question now.
So here there is a question, ma'am, is there any astrology something in Nagpur? Actually, I'm not aware. And of course, what I talked is all astronomy, not astrology. So maybe some other time we can have a interaction on this. Yeah. Okay. Yeah.
Ma'am, I want to ask you one question. Can you suggest some books or something for school students to
Okay.
explore more and be curious about astronomy and astrophysics?
Uh,
At school level, what should students be prepared for?
okay. At
So
school
that they,
level, I would suggest books. I cannot right now. There are so many books written by all these astrophysicists, life in space, and so on. But for school level students, I would say, because they are not going to read novels, right? Um, understand what gravity is, understand what weightlessness is. So whatever they are studying in regular studies only, that carries all that weightage. Look at the videos. You have, you are in a generation wherein a whole lot of knowledge is available at your fingertip, right? Which we did not have during our times when we were students. So go through the videos which are shown by these astronomers who have been in the space. You may be having a lot of doubts here right now. So how they must be eating, how they must be sleeping, how I mean a lot of questions, how they must be going to the washroom, how they must be having bath. Everything is very clearly shown. So try to understand that, and at the same time try to understand the concept, how it happens. So I would suggest to read those kind of books rather than reading some novels or anything. And of course, there are some books on observational astronomy written by various Indian authors also. Right now, I cannot get a name of
I
any.
can,
Yeah, maybe
may I,
ma'am.
may I? Ma'am, I remember when I was a school going girl, at that time I have read one book that was by Bharat Bharti about Yuri Gagarin.
Yeah,
And I
yeah,
clearly remember it was in a narrative sort of means story, how Yuri Gagarin made it to the universe, into the space first time. And that was really very nice. So
yeah, yeah,
they must be having their experiences written somewhere, and those who have been to the space.
yeah.
So that can also be
Yes, yes, of course. Yeah, actually speaking, in my case, when I was in school, I read a book written by Kelkar from Goa, one writer in Konkani, which is Brahmandatle Tandav. So how, I mean, I just read that book. It is like you have to go lie down on your terrace and just look above, okay, and what is happening there. So that inspired, that started in my mind that you need to, there is something which is very far and I don't know about it. Yes. Yeah.
yeah, very true, very true.
Yeah.
Okay, over to you,
Okay.
Radhika.
Yeah.
yes, I guess some Harsh has one question. He has raised his hand.
Ma'am, I know one book. It's called 100 Things to Know
Yes.
About Space. I think it's a really good book about space.
101, yeah, questions on space. Yes, correct.
Okay.
There was one question. Maybe I'll take that. That is there any vehicle which is made which can travel at the speed of light? Right? As of now, no. Yes.
Okay. So I guess that's all with the questions. So thank you so much, ma'am, for your wonderful and amazing session about this microgravity and gravity. And I'm thrilled to see the pictures of the astronomers who have been there. I would love to be there and live in a space colony. That
Yes.
space colony picture was amazing.
Yes.
Now I would like to invite President P.K. Ahluwalia of IAPT. Sir, can you please share your insights about this? Sir, we are unable to hear you.
Okay.
Yes,
I
sir.
hope you can hear me now.
Yes, sir.
Yes.
Yes,
Yeah.
sir.
It was a very exciting session, I must say. And I want to congratulate Professor Rajendra Singh Exploratory for organizing this particular program. I think it's it's something which is desirable, even though there are very many things available to us on the internet. Because when you see somebody talking, explaining, that makes it all very, very different. And I must say that Dr. Reshma has done a great job in bringing out the essence of the topic which was for the talk today. I think all who were present in this particular talk must have seen that how she took us from the watching of the sky to the modern day explorations which we are trying to do around us. And India is, leading that race. And tomorrow we have the Space Day. It is the first Space Day which we are celebrating. I think this lecture is perfect for that kind of an occasion. So wonderful. I think we have discovered a great communicator today. People will realize that we require such communicators to, bring to the lay persons the beauty of science and scientific explorations. So, with these remarks, I thank Professor Arvind Lakhotia, who is behind the scenes person here. He has done a great job. And Reshma, you are now our leader in IAPT regarding astronomy and the questions around astronomy.
Thank you, sir.
Though sometimes people confuse it with astrology, but
Yes.
astrology has nothing to do with astronomy as such, except the mathematical part of it. That's all physics.
Yes.
But rest of the thing is all guessing game and probability. And you may be very good at making those kinds of probabilities and guessing games. I really loved the presentation. It was very lucid presentation. And the kind of experience which I had with you, Reshma, during our regional convention meeting at Goa. I thought that we should really bring you out of Goa and let you meet people who require your knowledge. Let me tell the audience here that I was with Dr. Reshma, who is the secretary of the Regional Council Goa of the IAPT. And she took me around with her telescope, which is so handy to carry here and there and see the things around. I mean, the life has become so easy that you can have the astronomy equipment in your homes. And amateur astronomers have contributed a lot for the discovery of new objects in the sky. There are lots of people who are looking at sky to find out what you call these comets, and they are named after the discoverers. That's the beauty of it. So I think there is a lot which one can do. Very serious science can be done in astronomy and astrophysics. And as Dr. Reshma was saying, that you should be very good at physics and mathematics. So I would also recommend the same thing. But the most important thing is, as she mentioned, your inquisitiveness, that you are interested in knowing new things. And if you keep that inquisitiveness of why, how, and what, I think you will have a wonderful life also, because after all, it's not that this inquisitiveness is going to help us in science. It helps us in life as well.
Yes.
So I thank the organizers. I thank Dr. Reshma, and I really loved it. That's the only thing which I can say. Thank you very much.
Thank you, sir.
Thank you so much, sir. Now, for the end of this session, I would like to request Vice President of Vidarbha region of IAPT, Dr. Govind Lakhotia, sir, to present the vote of thanks.
Thank you, Radhika, and congratulations for the smooth conduct of this program. On behalf of IAPT and PRSSC, I extend my heartfelt gratitude to all students who have joined us today for this enlightening virtual talk on the eve of National Space Day, first National Space Day of our country. First and foremost, I would like to express our sincere thanks to esteemed guest speaker, Dr. Reshma Desai ma'am, who has delivered today's session from Goa. Thank you, ma'am, for sharing a galaxy of information related to space. Your insights into the vastness of space and the importance of scientific exploration have truly inspired our audience. Your passion for the subject and your ability to communicate complex ideas so clearly is really commendable. Special thanks to our own Ahluwalia sir, who has joined us today from Bhatinda. Sir belongs to Shimla. He is in Bhatinda today. We are grateful for your continued engagement and encouragement for initiatives like these to promote scientific awareness and education, especially in physics. I would also like to thank the Director of Exploratory, Dr. Seema Ubade ma'am, for shaking the hand with IAPT in organizing this event. Your mission and vision have made this collaboration possible, and we are grateful for your guidance, ma'am. Lastly, I want to acknowledge the efforts of members of IAPT, principals, and teachers across the city who have publicized this event among students, amongst community within a very short period of time. Thank you once again to everyone who have witnessed this beautiful virtual talk. Let us continue to explore the wonders of space and inspire future generations to reach for the stars. IAPT Vidarbha promises to bring more such programs for the school students in future also. Wish you a very, very happy National Space Day. Have a great day tomorrow. Thank you very much. We can
Thank you. Thank you very much.
Before ending this session, I just want to inform all the participants that for the online quiz competition, they will be getting a link today at 9 p.m. and they will get a time of 24 hours to watch the video, and the quiz will be based on the video, which will be going to conduct tomorrow at 8 p.m. So all the participants, all the best for your quiz competition, and thank you so much for your valuable time. Thank you so much, everyone.
Thank you.
Thank you so much, ma'am.